I'm going to take inspiration from a question that I heard and didn't begin to answer, and do a little sidestep, which is, I think it's important for you to hear this. And the setting, again, is it's the kind of edict, mandate, that sometimes comes down from some level above the basic coding developers in some management structure. And they get the idea that EBR is difficult. And so they demand to see a list, sometimes from me, or they demand it from their engineers, and the engineers then ask it from me. What is safe in so-called hot patching? What can I do without EBR, in other words? And the basic assertion is that we would not have invented EBR and paid that enormous money to build it had it not been necessary, right? And basically, the claim is that there's nothing you can do that you might think is safe, that is safe in this kind of hot mode. And what I mean by hot, let's be specific, tie down the word of hot patching. Patching is doing DDLs. And the assertion I'm making is that no doing of DDLs in the concurrent environment of ordinary OLTP, insert, update, delete, and select, in other words, in the environment of ongoing DMLs, is safe. It's as simple as that. So I'm now going to describe to you an experiment, and you could, each of you, do it on your own laptop, and I'm going to recommend that you do. And it would be far better if you just wrote it from scratch, given the inspiration that I give you by describing it, than if I were to give you some code, right? The code is almost brain dead. It's the thinking about it that's the important thing. So here goes. The assertion is that, the assertion from these managers up there, they know a little bit, of course, they're the most dangerous kind. It's that they know about fine-grained dependency tracking. So they know that, for example, if you need to add a new subprogram in a package for some purpose, you know, expose it in the spec because there's some new purpose, and if its name doesn't collide with any of the existing names, in other words, we're not talking about overloading, which could be tricky, then we can be sure that if you were to do this in a quiet system, even if there was an enormous closure of dependents upon the guy you want to change, you could just do create or replace, bring in the extra subprogram in the spec, and the whole edifice standing on top of you would remain valid. It's easy to show that that's the case in a single user quiet database test. And then the question is the following: is that safe in an environment where there's never stopping DML? When I say DML, I mean insert, update, delete, and for that matter, select going on. And the reasoning that these managers would use is, well, there's not going to be any invalidation. Therefore, that chaos, you know, whole cascading convoys of locks and who knows what, is not going to occur. And Oracle is well designed. It's all safe. The worst that can happen, they argue, is that there'll be some need to get a lock to do something, and the session trying to do this create or replace on the package will wait for a bit, but it'll all be good, and you'll get the answer you want. Loosely speaking, they are claiming that the same sort of safety that gives you the results you want in the presence of just competing, ongoing, constant DMLs themselves will extend to this domain too. Must be like that, they reason. So here's the experiment then that stresses that point, and it's the most stripped down, simple version of the proposition. So this is what I want you to do. I want you to write a little procedure who itself generates a package spec, and it'll generate the package spec in an endless loop, time and time and time again, with each new iteration making no semantic change, but definitely doing a recompilation. And you can just picture it now. So you're going to write procedure P and run it, and it'll run forever until you abort it, and it'll do an endless loop doing create or replace of the package in question. Okay? And the way you achieve that is like this. You have a constant in the declare section of the procedure, you know, statement, constant varchar2 big enough, gets, quote, and here's the spec of the package, the SQL DDL to create it. Create or replace package P, auth ID definer, is function F, I in integer, return integer, semicolon, end, right? You can picture that. And now, how are we going to recompile it and recompile it without making any semantic change? Trivial. We include in the start of it a comment, just dash dash, I am version question mark. And so then that's what this text looks like. I'll say it one more time. You go to procedure, no formals, just a bare procedure, and in its declare section, statement constant varchar2 big enough gets create or replace package p auth ID definer is dash dash I am version question mark function f I in integer return integer semicolon end semicolon, right, or end p or whatever I called it. Obviously the package and the procedure can't both be called p. I don't know what letters I said, but you know what I mean. You with me so far? And then in the body of this driver procedure, it's just an endless loop, and you've got another variable called n declared. N is a PLS integer, and it's initialized to 0. So the loop goes, just loop, and then it goes n gets n plus 1, execute immediate, not statement, but execute immediate, replace of statement, question mark, to char of n, right? You can picture that, can't you? Semicolon, and that end loop, and that just will go forever and ever and ever, right? We'll come back and we'll put in a little sleep delay in that loop, but you've got the basic idea. And if you ran that in a single user quiet system, I mean your own laptop with a database on it, you would imagine being able to set off that, and it would just run forever and ever and ever until you in some way went off as sys elsewhere and killed the session. So far so good. Why did I fuss about the question mark and so on? Well, you've got to do something, and there's a risk here that if you don't know enough, you might fall into a trap. You might think all I need to do is just create or replace the same text time and time and time and time again, because that's compiling it. Why do I need that fuss with the question mark and the comment? It's this. We have a cunning optimization that maybe we don't make a fuss of, because after all it delivers its benefit, and then net result is things go quick when they might have otherwise gone slow. We don't need to give away every detail of how we do things, but in this case it's important to know we have an optimization that we always refer to informally as the source code and settings identity optimization. The backstory is that back in the day when eBusiness Suite were doing their patches, they were too lazy, let's say, to discover exactly which packages needed changing and which didn't. They just, run the script to creates and replaces every single package, where some of them have been changed and some have been and not, Same with the database, for that matter, itself. And of course, in the early days, then you'd be doing a ton of compilation to produce the same result that you already had. So not surprisingly then, we introduced a little trick who says this source that I'm supposed to compile, do a MD hash on it, is it the same as the MD hash that comes off the source I've got down there? If they're the same, I'll just do nothing. It's not quite just the source text, because if you think about it, these settings, alter session set conditional compilation flags equal blah, blah, blah. Alter session set optimize level, blah, 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 blah. So they also are part of the definition of the unit in question. It's in a way a little bit annoying that some of the definition is the actual source and other bits of it is floating around in the air, but you know what I mean. So if we discover that the settings that you would be running with are identical to what's stored with the unit, you can see them in DBA PL/SQL object settings, and the source is identical, we do nothing. So in this experiment, if you didn't know that, you'd just run around an endless loop doing nothing. You'd think everything was completely safe, you'd be fooled, and you wouldn't be testing anything. So that's why I've got this little device. I'm changing the source text by changing the spelling of the comment, and that's sufficient to ensure that a compilation is taking place every trip around the loop. You still with me? So far so good? You could go away and write such a procedure? Yep, good. So now what we want to do is arrange that in another session we're going to use it, but not use it directly. We'd better use it through a dependent, because that's part of our proposition. The idea is that a dependent will never go invalid and everything will be good. The worst that can happen is a little bit of waiting. So the dependent is just a pass-through function, Function X, auth ID definer, is my package, whatever I called it, p.f. At least return p.f of I, and this function's got I in integer. You with me now? Just a pass-through jacket around the function that we wrote. So the package exposes, let's say the package is called p, and it exposes function f, I in return integer, and now our jacket is j for jacket, function j, I in integer, return integer, auth ID definer is return p dot f, if those are the letters I said, of I. Yes? Make sense so far? Right. And then we arrange to use that in another endless loop. So all we do is in a loop, we have an n, same as before, declared, and the loop starts n gets n plus 1, and we go insert into t values, that thing I just said, j of n, right? And what's t? T is a convenient table that we created for this experiment, who's got an integer column, and it's got, obviously it'll have some surrogate primary key of a identity, as it would be in 12, so we can see how many rows we put in there at a glance. Still with me? So you can imagine then you set up two SQL pluses. In one, you run the create or replace constantly in its loop. In the other, you run the insert into table t constantly in a loop. The only thing now is we arrange some timing because we're interested in race conditions. So bear with me. You know dbms lock.sleep. It sleeps for a certain time. It just sleeps for an interval. I want to sleep until, let's say, an integral number of seconds, whole seconds, has elapsed since the instance started. Who cares when it started? It might be 1,000,000 seconds since it started, but I just want my thing to wake up on the whole seconds, yes? And I want not just that, I want it to wake up on the whole seconds plus a little delta that I can adjust. Still with me? So I can arrange that easily enough by reading this dbms utility dot time, which reads a centisecond clock, and 100 centiseconds is 1 second. So I can arrange to sleep for a shorter time, wake up, ask what that clock reads, sleep, wait, and it doesn't even matter. This doesn't have to be efficient. I could just read it in a tight loop without sleeping. But let's say I sleep for nominally 1 centisecond at a time with dbms lock.sleep, and I wait until dbms utility dbms-utility.getTime returns an integral number of hundreds of centiseconds. Yes? Still with me? And I can clearly add a little delta as well so that it goes on that. And now I put one of them, a call to that guy, sleep until, in each of those loops I talked about. And I'm aiming to make them go in dead synchronicity exactly at the same moment. Of course, they can't go more exactly than plus or minus a centisecond, but that's good enough for my test. First thing I do is I just deliberately set the delta on 1 so it comes exactly in the gaps of the other. They're exactly in antiphase. So this one goes on blah, 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 100, blah, 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 200, blah, 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 300 in centiseconds, and this one goes on blah, 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 150, blah, 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 250, blah, 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 350, and so on. They're exactly in antiphase. I expect you can guess, this is just 2 sessions, your laptop, that you could start off one loop. Doesn't matter when you start off the other because they'll be synchronizing on this, external clock. And then they'll just be happily going on, each going in the other's gaps, yes? And when the recompilation takes place, it's got enough time to take place, and the net effect is no invalidation anywhere, so there's no consequential recompilation, and everything is comfortable. With me so far? Yes. And I really, really, really encourage you to do this, set up to do it, and observe that. Then what you do is you crank back the delta. You don't have to go as far as having them exactly on the same moment. That's not such a vivid demonstration. I've discovered that about a lag of 5 centiseconds between the two is enough to get a really convincing outcome, convincing with respect to the point that I'm now making. What you see is, in the most forceful demonstration outcome, the 2 sessions will continue running with no perturbation for maybe 1,000, 2,000 iterations. You could sort of let it run for 10 minutes and it might be perfectly, apparently happy. And then suddenly, one of them will report an error. And the one coming out of the one using it might be 4068, package state discarded. And you might think, well, that's bollocks. There's no package state here, which is clearly the case, this is a bug in Oracle. In some theoretical sense, you might try to argue it is a bug, but we wouldn't accept it as a bug. What's going on here? Now, you'd never know a priori unless I give you this story, right? So that's critically important, another thing I can give to you. It's this. It's very abstract. Cast your mind back maybe 20 years or something like that. What was Oracle's whole corporation's principal business goal? You know, what did it talk about with its stockholders? It was Oracle database will be, or already is and will continue to be, the absolute world beater in performance in these benchmarks that are publicly agreed and that are arranged to stress performance in OLTP situations, right? I don't have to name them, it's some STP or FT, I forget those letters, but you know what I mean. Yes? Still with me? Oracle's goal was to be fastest in that. Now, another thought, if you've ever gone to a conference presentation by Jonathan Lewis or Carrie Millsap or people who've been inspired by them, they always say the same thing, which is if you want to improve the performance of something, the most blindingly obvious and clearly best way to do it is by not doing it. Yes? If it used to take X and you don't do it at all, it's now taking 0. That's a notable speed up. Okay? And obviously, a lot of engineering is inspired by that. So now we've got to ask, given the business goal of being best in breed in these benchmarks, how could Oracle make things fast as possible by avoiding to do certain things? The answer is obvious. What was the benchmark spec? All these SQLs of all these kinds doing insert, update, delete, and select in million specified parallel sessions. Did the benchmark spec include any DDLs going on? No. So clearly then, the engineers took the very sensible design choice that they would orient the whole approach to be most efficient in that by not doing a lot of work to make the outcome in the presence of concurrent DDLs absolutely quietly happy, you know? That's the right thing to do, isn't it? And had they not done that, everyone who is so satisfied with the good OLT performance of Oracle would be dissatisfied. Clearly, you could do the kind of testing that's done in the ordinary case of competing insert, update, and delete from various sessions, do a similar game in the presence of competing real DDLs, just by having the right system of locking and queuing and all sorts of things. It could be done, but that would slow things down. So it wasn't done. However, the engineers doing this, planning it, still had to honor one goal that was absolutely non-negotiable. And that is, in the event that someone does something stupid and insists on doing hot DDL, that's what we mean, they insist on doing hot patching, we couldn't let that result in dictionary corruption, right? Because that would be too bad an outcome. So we're not aiming to be absolutely well-behaved and patiently wait and all the right locking for that. We're simply aiming to abort something when our optimistic assumptions proved in the moment to be unsound, yes? And the reason we abort is rather than comfortable end-user experience, just to avoid dictionary corruption in the case that you were too stupid to avoid the myth of hot patching. Do you follow me so far? Do you think you could reproduce that reasoning? I mean, it's entirely plausible, isn't it? It's very high level, it's very abstract. And you don't have to talk any details of locks and latches and library cache and contention or anything like that. It's just an abstract proposition. You get things faster by scoping out some of the things that you would attend to in some other goal space that would make you slower in this goal space. It's how you presumably go about your daily job. So there we have it. Why do we get 4068 package state discarded, and why did we get it sometimes and other errors on other times? Because the goal was not to give the most useful and exact error messages. Because fussing with that would have slowed things down even more. The goal is just to give some or other error that's sufficient to avoid blundering on and corrupting the dictionary, never mind if it's the most useful message to you. Because the high-level message is just bang, alert, oh, of course, shit, I'm doing hot patching, I shouldn't be doing that, right? So what I'm now trying to say is that that experiment, which is so sensitive to timing and can, in the case I just mentioned, run for many, many iterations before reporting an error, that's enough to show that any naive analysis of this, of the kind that these manager people I used embody, won't spot that. And any little one-off test will only prove it's safe. Of course, it won't prove it's safe. It'll only not disprove the idea that it's safe, as we know from Popper and all this business of the philosophy of science. So then that's the experiment. And what I'm now going to just assert is that given that we don't document any contract that states you may certainly safely do DDLs just on a whim all the time in the presence of ongoing OLTP, you can only assume the opposite. I've given you one example where common sense should indicate that the outcome is safe, and yet reality shows that you get randomly occurring errors, and the high-level explanation I gave you lets you understand why you get them and why they're not even worded that usefully. There's only one assumption you can make, and that is that no DDL in the presence of ongoing DMLs is safe. Okay? There's just no such thing as safe hot patching. Simple as that. Unless, and I've even talked with a middle manager who defended this stance, you're going to let end users suck up, random error, try again, right? I don't think that's a comfortable stance. You can't write an exception handler to catch these guys because they are, in the formal sense, unexpected. You've got nothing sensible you can do. This guy thought the sensible thing was to report to the end user interface, something strange happened, try the Microsoft approach, as I just did with my Apple. Try again, you know, and maybe it'll work next time. But let's assume we just don't want that. Therefore, you can't handle the exceptions and swallow them. The only thing you can do is avoid getting them, and you can avoid getting them by not doing hot patching. Have I solved that point? Are you convinced? Right. Now, there is one kind of special exception to that, and I'd be dishonest if I didn't mention it. Some applications, they're very few and far between, but they exist, gather facts from the UI, and on the button press, they deduce from that corpus of facts that just came in the plan for computing up a whole new procedure. You know, they do dynamic creation of a PL/SQL procedure in response to some end user information. And then they wire up that procedure into their whole fabric of code, which they have to do using dynamic invocation, but you can do that. So this is the real design. Now, if you think about it, and given the explanation I gave, if they aren't very, very careful, they would get these random occurring errors too. However, they could be careful by implementing their own scheme of lightweight notions around locking and stuff like that. You know, they could make sure that in some way they quiesce any user activity that's going to cause use of this thing, and then they replace it, and then they let the end user activity in again. In other words, if you really know what you're doing and you go about it in a very careful way, then you can do a DDL in the presence of online DML safely. In this situation, though, it's a super, super, super special case. The guy you're doing create on replace on has no direct dependence, no static dependence, right? And you can arrange that at the moment you do this, you know there are no ongoing invocations of it because you're in control. But that's not the spirit of what people think they mean when they say hot patching. What they think they mean when they say hot patching is blasting one thing in, having reasoned that that can't possibly do any harm. And that's what your scenario was. Now let's look at that then in an entirely different philosophical stance from a different stance. It's this. If you have in your whole database a mechanism that lets you do zero downtime and completely safe, not just patching, but real genuine upgrade of lots of PL/SQL objects in concert, why would you ever want to do hot patching? Why would you not just use that mechanism? And this is the scenario that our man put up with, I dare to say, I risk to say, without really joining the dots of what he was saying. So you've got an EBR exercise ongoing. How long is it going to be ongoing for? Not that long, you know, maximum, I don't know, half an hour or 2 hours, I don't know. That's still not long, is it? So during those 2 hours, exactly during those 2 hours, you observe some fault, you diagnose it, you trace it all down to one particular PL/SQL package, you've done all the testing you could manage in all the test dev environments, you're absolutely certain that you found the cause, all in 2 hours, and you're so desperate to get it done that you can't wait till that EBR exercise is finished in its normal way and then do that. Or really what you would do is you would notice, well, I'll just do one last thing in that EBR exercise that I hadn't thought of doing and let that EBR exercise bring that as well. After all, it's bringing various improvements. Why wouldn't it bring that too? And you've got this prepared in secret and not yet in use world. It's the perfect place to do it. So really your question, which I didn't repeat, but you can guess what his question was. His question was, I'm in the middle of an EBR exercise and I've suddenly got to do some hot patching, and it was in the context of this here shine through story. Where's that gone now? This, you know, change object 3 on and on and on. What do you do? How do you get out of that? Well, I've just told you now, you don't think about it that way. You step through the analysis of how could that happen and just how impatient you have to be before this becomes a real problem. Does that convince you? Or do you still think you have a genuine...
It wasn't for production. It wasn't my question.
Yours? Yes. Yes, exactly.
Not really.
Well, okay, this is important.
The question was just, is there any kind of reference still between the versions for an object in regards of the inheritance when you have changed for the object 2 there, in this scenario? If you now change in version 1,
Yes?
do you have any kind of reference still to version 2 object between the one?
Oh, I see. I understand the question. First of all, I will say in my defense that even though I answered a question that nobody asked, I answered a question that these middle managers are asking all the time, and it's critically important because you can guarantee if you're ever involved in a deployment of EBR, there'll be people asking you that question. So now your question was very down to earth, but it's still, dare I say it, about the angels dancing on the head of a pin. The question is, should I, even though I know it's, what's happening here? Even though it's not a safe thing to do, in the environment of constant ongoing DML here, should I, if I change number 2, does number 2 star care about it at all? And the answer is no. You cut the umbilical cord the minute you diverged and did a separate create replace on that. But I don't recommend that you take any particular advantage of that knowledge. Now then, what was your question, if it wasn't what I thought it was?
My question was that, let's say, you drop object 1
Yes.
in edition number 2,
Yes.
but then you do an insert into object 1 in the old edition.
Ah, okay.
How is that handled? That was my question.
Okay, well, I can tell you how it's handled. Again, it's angels on the head of a pin, but when you do the command to drop number 1, given what I'd said about how this shine through works and so on, what you actually do is change the definition of that link to, instead of meaning I'm pointing back there, to saying I don't exist, you know, and you can even see that there's an object type called non-existent if you look through the stuff there. Now I should say don't be too attached to that, because I told you that this whole shining through business and everything is regarded as a bug and that we will someday fix it. And when we do someday fix it, we can reimagine what we mean by these links. And if the link's not there, it won't be shining through, so to speak, and that would work too. But suffice it to say that in this situation you'd never encounter, if you have first dropped that, then no matter what you do to that, it won't shine through. But there's yet another important point to make here now, and it's slightly hard to get your head around it, but I think you can do it if I just say it. I'm going to introduce you to the concept of consequential actualization. So all we've seen so far is deliberate actualization. I wanted to change object 2, so I did it, right? Create, replace. Now imagine this. You want to change object 2, but I hadn't told you this before, now I'm telling you, object 3 happens to have a static dependency on object 2. Or to put it another way, object 2 is the dependency parent of object 3. Or to put it another way, object 3 is the dependency child of object 2. Okay? So before I say what I'm going to say, I'd just like you to consider a scenario. Suppose you go down to a pub, or let's imagine people going down to a pub. Suppose there's a man and a woman in a pub. It's important that one of them is a woman, just for certain biological reasons of how the birth process in human beings takes place. So, not to give the game away, they're chatting away, and their conversation is going very well. And the man is quite interested in the woman, and it seems to be reciprocal. And then the woman says, "There's something quite fascinating about me. I bet you'll never guess, so I'm just going to tell you. Actually, I am older than my biological mother." What would you then think? Never mind whether you thought your thoughts with colourful extra vocabulary thrown in. I think you would think, this woman's talking nonsense. Do I, A, try and convince her, or B, ease myself out of this conversation before it gets too hard? But one thing is sure, I think you're convinced that what she says is nonsense, yes? This woman is saying that she is in actual fact older than her biological mother, yes? Now, if someone asked you in an exam to produce a formal proof that that's nonsense, I bet you, like me, would have a hard time doing it. Maybe you could knock up something in common sense, you know, like if that, it must be this, cause, yeah, but you'd have a hard time to do it formally. Never mind, you know that it's a sort of a conundrum, it's an impossible situation, right? A child cannot be older than its parent. Now, in this world, age is going from left to right, right? Sorry, well, I'll put it without left and right. I'll just say that the parent edition is on the left and the child edition is on the right. The edition on the right is younger than the one on the left, right? And therefore, all the objects in the one on the right, in the child edition, are younger than the ones on the left, right? So before you do anything, object 3 depends on object 2. They're of the same age, so to speak. Now you've got a different and younger parent. And now this child is trying to say it's older than its parent, right? That doesn't make sense. Can you see then that as a consequence of actualizing that, this guy, who is a dependent on that, must be consequentially actualized here. So this is dependent on that. It would be object 3. You could call it 3 star, but its actual definition is indistinguishable from 3. It's just its ultimate meaning is different because its dependency parent is the changed object 2, not the original object 2. Are you with me there? You follow that? So there we have consequential actualization. Now, in many cases of designing a patch, these are the create replaces I need to do. You wouldn't have the energy to compute up beforehand just what would be consequentially actualized and what would not. You could, if you really took your time about it, but it's not a scalable approach, you know. I think from that you can only conclude that considering objects like 3 and 4, you simply don't know in this kind of black box situation we were talking about, where you're doing illegal hot patching, you don't know if object 3 will shine through or if it's covered by a consequentially actualized successor to it. See what I mean? In any particular one, you could do some dictionary queries and find out, but you couldn't comfortably have a general way of using the idea of shine through, even under any circumstances. Okay? Does that make sense? And that just leads us to the last point in this here very oddball case, where as part of ordinary runtime activity, you need to generate PL/SQL. And whatever mechanisms you've done, you've convinced they're safe enough. So just as, do you know this expression, what's sauce for the goose is sauce for the gander? It means if you've worked out some set of principles that apply here, and if this is a very similar situation, then the same principles had better apply over there. Goose and gander being the male and female versions of a goose, right? So then, the point is this. We worked out that in hot rollover, you need bidirectional mutual synchronization. The effect of something you do in the old must appear in the new, maybe slightly refactored. The effect of something you do in the new must appear in the old, maybe slightly reverse factored, yes? Well, so it is with this, then, dynamic generation. If you dynamically generate something in the old, you must also dynamically generate it in the new, possibly using a patched version of the generator code. And similarly, if you generate it in the new, using possibly a patched version of the generator code, you'd better redo it in the old, using the unpatched version of the generator code. So it's the same idea, roughly speaking, as it ever was. You, though, by hand, have to use mechanisms that we've got that are not part of the normal set, and not what I'm explaining here, to deliberately make sure that you know there's an exercise going on, and then do the program creation both in the old and the new. Now, that was maybe too much information for you, but what I want to get across with that little speech is a meta point, and that is, I think I can safely say that no matter how convoluted and twisted and devious the use case you come up with is, we'll be able to find a way using the basic primitives of EBR to do the job. Okay? And the clue in that one is something I'll just mention briefly. There's no time to talk about it much. You know DBMS SQL, and in particular DBMS SQL.parse. DBMS SQL.parse has got more overloads than I've had hot lunches. I don't know if you've noticed. And they keep on coming. And one of them exactly has a formal parameter called addition. And that lets you say, this SQL statement, here and now, that I'm giving you, do it in that addition. I told you earlier it's unsafe to switch additions during an in-flight server call. Here it's a special kind of safe switch. It's a bounce in and a bounce back. And for that reason, we normally call it the DBMS SQL trampoline. I know I'm saying, in a way, stuff that's going slightly over your heads, but there you've just got there, you know, if you remember, if sometime you're in that use case where you want to do one single shot SQL in a different edition, we've got a mechanism. You bounce in, you bounce back. DBMS SQL trampoline is what we informally call it. So then I think I've done the whole idea of the addition to death. And now it's on to the rest of the story. And this is where I, first of all, start playing with words. It's somewhat unfortunate that the word version was already used up. You know, if no one had ever used the word version on the planet for anything more than informally in conversation, and if we'd invented this, we'd have picked version, where instead we picked addition. But we just felt we couldn't use the word version because it had too many existing uses. Which version of Oracle are you, which version are you using now? This problem we're talking about. You know, do you mean the hot patching version of versions, or do you mean the database version of versions? You know, it would be just too confusing. So we just had to get down the big thesaurus and look for a word that was the same as version, only wasn't it. And the best we could find was addition, right? Now, version has already been Americanized in the sense that it's a noun in good old British English, full stop. But they make everything into a verb, and once you've made a noun into a verb, you've got all the inflections. So you wouldn't be shocked if you heard someone talking about versioning. Have you done any versioning recently? Yeah, I did some yesterday. Or, you know, what about this thing? Is it versioned yet? Yes, it is. No, it's not. You know, this apparatus is great for doing versioning with, and I've been using this, and I've done some versioning, and I versioned that, and I versioned the other. But I couldn't version that one, because that one's not versionable. Yeah, all these words just fall off the tongue, right? And they don't seem awkward. Well, we just had to suck it up and do the same for addition.